Hello, you are welcome to today's lesson. My name is Paul Williams of Virginia. Today we have science for Basic 4. So all those in Basic 4, please, we have a lesson. Those who are not in Basic 4, you too, please come. We need you around. Today's topic, your class teacher will teach you. That is why I'm saying come around and let's learn. Today we have a science lesson for Basic 4. The topic is here. I have mentioned my name, so you to do the same thing for me. Go to the comment section, write down your name where you are watching me from. Okay, so let's look at the topic for today. We are looking at elastic and compressional force or forces. Let me read it again. Elastic and compressional forces. Today's topic is about forces. We have learned about force, a pull or a push on an object. Very good. So today we are looking at some types of forces, and the forces that we are going to look at, there are two: compressional force and elastic force. That is what we are going to look at. Okay, so let's look at the keywords. The first word here is elastic. Elastic. We have compressional. Compressional. Spring. Spring. Shock absorber. Shock absorber. So these are some of the words that we are going to find in the lesson. So just exercise patience, you get to understand all of them. Okay, I said that we are looking at forces. Okay, so in our everyday activities, we apply force to move things, to stop things, and to do many things. We use force to close a door, move a table or a chair, wring water from clothes when washing, and others. The direction and speed of the moving ball can be changed when force is applied. So the question is, what is a force? A force or force is the push or pull on an object. We have different types of forces or different types of force. We have the gravitational force or force of gravity. We have magnetic force, we have frictional force, elastic force, compressional force, and others. So today, we are going to limit ourselves to only two types of forces. These forces are the elastic force and the compressional force, or force of compression and elastic force. So these are the two forces that today we are going to look at. We have different types, but today we are looking at only two. You see, there are not many, so you understand it. And I'll take my time to break it down for you to understand. At the end of the lesson, you'll be able to differentiate compressional force and what? Elastic force. You'll be able to tell the difference between compressional force and elastic force. Okay, so let's look at it. What is elastic force? What is elastic force? Have you heard about elastic before? Elastic. How does it look like? Elastic. Okay, so let's look at it. So elastic force is the force that allows an object to return to its original shape after being stretched or compressed. Note that not all materials or objects can be stretched or compressed and return to their original shape afterwards. Elastic force can be found in rubber band, coil spring, catapult, slingshot mattress, spring, elastic waistband, and the rest. So we are talking about elastic force. The materials that we see around, some of them have force in them. the materials, some have force in them. And what the force in them do, or these force that we have in these materials, what they do is that if you stretch that material and you release your hands, the force in them will what? Bring them back to their original shape. If you compress the material or the object after you have released your hand, the force in them will push it back to the original what? State. The force inside the material that restores it when it is compressed or stretched, that force is called elastic force. Elastic force. So let me show you something here. Let me show you something here. Okay, so let's assume that this is spring. Or let's take this. This is spring. If my hand is here and another hand too is here, and I compress it, I make it shorter, you see the size will reduce and I'll have something like this. So the spring will be like this. You see, it will be reduced to this state if I compress it, or if I put them together like this. You see the size will what? Reduce. But the moment I take my hands off, it will go back to this side. Why is it that when I press it, the size here did not remain like that, but after I release my hands, they pushed back to the original length or size? It's because of force that we have in it. That force in it that pushes it back to the original size. That force is called elastic force. That force is what? Elastic force. So elastic force are in objects. What they do is that if you stretch the object or if you press it, after you have taken your hands off, they will what? Go back. The force will push the material. The force is inside, so it will push the object or the material to its normal or original shape or size. So the spring, I'll compress it to get this, but if my hands are not there, the spring will go back to its shape. What pushes them to the original shape is what we call the the elastic force. That is what we call elastic force. So elastic force they are inside the objects or material, and what they do is that they restore the objects. They restore the objects. It makes sure the object goes back to its original state. Okay, so let's move on. So let's look at activity 1. Activity 1, the focus is to demonstrate elastic force in an object. So the focus of this activity is to show or demonstrate elastic force in an object. Materials needed: rubber band, catapult, and paper. So these are the materials that we are going to use, these 3 materials. Okay, how to go about it? 1. Hold one end of the rubber band with your right hand and the other end with your left hand. 2. Stretch the ends gently for a few minutes and release the rubber band. Okay, so I have rubber band here. This is my rubber band. The instruction says I should hold both sides and stretch it. So have you seen it? Look at the original size or shape. Can you see it? This is the original shape. Now I'm holding the ends. Let me see if I can stretch it. Okay, so you see I'm stretching it. The size is expanding. Have you seen it? Have you seen it? If I stop stretching it, I also have it like this. I can even stretch it again. But if I stop, you see, it is not stretched again. The original size, now it has come back to the original size. I stretch it. When I stop stretching, it has come back to what? The original size. Why is it that when I stretch it, it did not remain like this, but rather, when I stop stretching, it has come back to the original size. The force that brings it back to the original size, that force is what we call elastic force. So elastic force are in the object, or elastic force is in the object, and that force brings the object back after it has been stretched. Sometimes if you press it, if you press an object and the size reduces, when you take your hands off, the object will come back to its original shape or size. It is also the elastic force in it that pushes it back to its original shape or size. So the elastic force, it happens, or we see it when something is stretched and the hands that is stretching the thing takes off or is released. When something is pressed and you release that thing, you see that first when it was pressed, the size reduced. After you stop pressing it, it will come back to its original size. So the force that pushes or restores the size of an object after it has been pressed or stretched, that force in it is called elastic force. So there is elastic force in this. That is why when I stretch it and I stop stretching, I still get the size. Okay. Now, there is another one here. Let's read the instruction and see. So the third one is that hold the catapult and repeat step 1 and step 2. I don't have catapult here. Number 4, hold a paper and repeat step 1 and 2. So there is a paper here. This is a paper. Let's look at step 1. Hold one end of the rubber band. So we are going to hold both ends of the paper. 2, stretch the ends gently for a few minutes and release the paper. So we are going to stretch it for some few minutes. Let's see. You see, I cannot stretch it. It is not going. It is not moving. Have you seen it? Have you seen it? It's still not moving. Unlike this, that I was able to stretch. Look at this. I was able to stretch. Look at the size. Just look at the size. If it is not stretched, look at the size. But I can stretch it and make it even longer than the paper. Have you seen it? But the paper, I can't stretch it. The same size. Have you seen it? But this one, I can stretch it. Have you seen the size now? But if I release my hand here, there is something in this that will send or restore the rubber band to its original shape. So let me take my hand off. Look at the size. I'm taking my hand off. Now look at the size. Have you seen it? Okay. So what is inside this? The thing that is inside, the force that is inside, that brings it back to its original shape. That force is what we call the elastic force. This one doesn't have elastic force. One, because it cannot be even what? Stretched. The size is fixed. You can't stretch it. If you try it, it will tear. Okay, so here, let me put this down. So let's look at the conclusion. In conclusion, rubber band and catapult were able to stretch and return to the original shape when released. The paper was not able to stretch and rather tore into pieces. I didn't put too much pressure on it, so mine did not tear. The next one is that this means that not all objects have elastic force which allows them to be stretched or compressed and return to the original shape. Rubber band and catapult have elastic force, but paper does not have elastic force. Paper doesn't have elastic force. That is why it was not able to be stretched. It was not also we couldn't compress it. So that is what you should know. What is inside a material that allows it to be stretched, and that same thing allows it to to restore to its original shape and size. That force is what we call the elastic force. Now let's look at the importance or application of elastic force in our daily activities or in our daily lives. So why do we have to get objects that have elastic force? Why do we need them? How do we use them? So the first one, elastic force in springs hold our doors and gates tight and firm. So if you look at this is a gate. Have you seen it? We have spring here. The spring will help you to open it, and when you open it and you leave it, you see that the spring will pull it back. It brings the door back to its position. Okay, so it helps us to hold our doors and gates tight and firm. The next one, elastic force in some clothes hold our bodies and makes us feel comfortable. So if you have this as your dress, you see this side, this is the waist. There is elastic material there. That elastic material makes sure that the dress fits you well. And the same thing too is here. This material too, if you wear it, yes, it will fit you, or you can stretch, and when you stretch, it will come back to its original size. The same thing happens here. Here, the waist you can stretch, and when you release your hands, it will come back to its original state. So we say that elastic force in clothes holds our bodies and makes us feel comfortable. Okay. The next one, elastic force in rubber band helps bind books, money, pencils, and other objects. So what I shown you, this one, elastic force in it helps us to bind objects. Okay. So we use it to bind objects like this one, this is money. Yes, so you see the rubber band. Okay, the next one is that elastic force in catapult causes stones to fly. So if you have this is catapult. If you put stone here and you stretch it, because of the force in the rubber band or the tie, it will make sure the stone flies to a particular direction that you have directed it to. Okay. The next thing that you should know about elastic force is that elastic force in bungee cords holds or ties objects. So you see some motorbikes and bicycles have this. They use this to tie objects at the back of their motor or bicycle. Okay. The last one, number 6. Do you know any object that has elastic force? Share your answer with your friends. So here we are asking, apart from the things that we have mentioned, do you know any other object that has elastic force? If you know it, share it with your friends. So we have seen what elastic force is. These forces are found in objects. Because of this force, the objects are able to be stretched. And after you have stretched the object, the force will bring the object back to its position. Because of the elastic force in it, even if the object is pressed or compressed, the force in it, which is the elastic force, will make sure that the object will restore to its original state. So that is what we have learned about elastic force. Now let's look at the other type of force, that is compressional force. So it's a force that presses or pushes something together, making it smaller or shorter. Compressional force causes objects to be pressed, squeezed, or reduced in size. So for compressional force, this thing doesn't have compressional force, but I just want to show you how it works. For compressional force, you hold two sides and you can press it. Look at the size. So look at the size. You see, I'm pressing, it is reducing. And so objects that have that force in them the force allows it to be what? Pressed. And when it happens like that, the size of that object reduces. The size what? Reduces. Or it becomes shorter. Okay, so that is for compressional force. Let's look at this activity. Focus is demonstrate compressional force in objects. Materials needed is spring and stone. How to go about it? So take the spring and press both ends with your two hands. So you take a spring, hold the two sides and then you press it. Number two, release your hands and record what happens to the spring when pressing and after releasing your hands. So we will look at it. Third one, take the stone and repeat step 1 and 2. Okay, so this is the spring. You hold both sides and you press it. You see that if you press it, the size will reduce. It will become smaller and the size will reduce and become shorter or smaller. So here, because of the force in it, that force that allows it to be what? Reduce. That force is called compressional force. So anytime compressional force is seen when an object is pressed, make smaller. So if you press something and it becomes smaller, it's because of the force in it that has caused it to become smaller. Now after you have pressed it, the thing will come back. That object will expand or restore to its original size. There is force in it that causes it to restore to its original size, and that force is what we learned earlier. That is elastic force. Okay, so now let's move on. In conclusion, when the spring was pressed, the length became smaller, but returned to its original length after releasing the hands. The stone could not be pressed, and the shape and the size remain unchanged. This means that compressional force enables objects to be made shorter when pressed. So what it happens is that with compressional force, it makes object shorter. Okay, now if you have a stone and you press it, the size will be the same. It will not become shorter. Okay, but with spring, the size or the length will be reduced, or it will become shorter. Okay, now let's look at the importance or application of compressional force. The first one is that compressional force in shock absorbers help cars to move over a bump smoothly. So this is shock absorber. We have this in our cars where the tires are. So it's helped the car to be in good position. It balances the car when it is moving in rough and potholes. Okay. So if the road there are a lot of potholes, the shock absorber will help the car to be in, to balance well. Okay. The next one is that compressional force is used in squeezing water from cloths. So this is an example. As for compressional force, we know that anytime we apply this force, it reduces the size and it makes the object smaller. So if you look at this is not the actual size of the cloth or the dress, but because of compressional force and it is squeezed, you see the size of the dress has reduced. Okay. Number 3. Compressional force is applied when pumping bicycle tires or footballs. So you have bicycle tire here. The pump. Have you seen the pump before? There is spring in it, so we pump it like this. And it helps us. We use, because of the compressional force, you are able to bring it up and down, up and down. And that helps us to what? To get our tires filled with air. Okay. The next one is number 4. Compressional force is used to squeeze juice from fruits. So we are able to press juice. We are able to press fruits to get the juice because of what? Compressional force. So have you seen it? Compressional force always reduces the size of it. Okay, when we press it. Okay, so do you know any other object that can be compressed? Share your answer with your friends. So apart from the object that we have seen, is there any other object that we can compress? If you know it, share it with your friends. Okay, the next one is the effect of forces on objects. As for forces, effect of forces, we have learned this, and I know you will not find it difficult again. So force can stop moving objects or objects in motion. So if something is moving, going, we can apply force to stop it. The next one, force can increase speed of moving objects. So if something is moving and you want that thing to move faster, you can apply force for it to move faster. Okay. Third, force can decrease speed of moving objects. If something is also moving faster and you don't like it, you can apply force to it and then the speed will what? Reduce. Number 4, force can change the direction of a moving object. Yes, so it's like football. If I kick a football and it is coming to you, you too, you can kick it and it will go to different direction. You kick it by applying force. So we are saying that force can change the direction of an object in motion or object that is moving. Number 5, force can change the shape and size of an object. So the shape of an object, the size of an object, force can change it. For example, here, have you seen it? This is not the actual size of orange, but because of force, the size has been changed. Okay, the next one is that, the last one is that force can move stationary objects. Stationary object means something that is at a point, it's not moving. So if you have a desk, a chair, and the desk is at one point, you can apply force to it and it will move. So force can move something that is not, or something that is at a point, a stationary object. Okay, listen, this word is different from another one. The other one has E here. The other one has E here. Here is E. That one we are talking about writing materials, books and the rest. But if we don't have E, but we have A here, it tells you something that is not moving, something that is at a point. Something that is what? Not moving. So force can move stationary objects. Something that is at a point, something that is resting, force can move it. Okay, now in summary, what have you learned? We have learned about elastic and compressional force. We have seen objects that possesses elastic force and objects that possesses compressional force. Okay, so today's lesson, we are bringing it to a close. What we have learned is that elastic force and compressional force, they are in objects. The elastic force helps restore an object when it is stretched or compressed or pressed. Compressional force too is a force that causes or that helps us to reduce the size of an object. So external force comes together, press an object to reduce the size. That is compressional force. We see this in mattress, we see it in other objects. We have also seen that catapults and the rest, they all can be stretched, and because of that, they have elastic force. After stretching, they come back to their original shape and size. Okay, so today that is what we have learned about two types of forces, compressional force and elastic force. Listen to me. The elastic force is a force inside the object. That force helps the object to restore to its original state, form, or shape. After you have stretched or you have compressed it, it is the duty of the elastic force to make sure that it will go back to its original state. But compressional force is an external force that reduces a size and shape of an object. So there are some objects that have this force. Some objects who do not have that force in them, like stone. It doesn't have compressional force, so you can't press it to reduce the size. But spring has compressional force. That is why we can press spring. And if you press it, the size reduces. It's because it has compressional force. Okay, so that is what we have learned today. Let's look at the exercises. We have exercise 1, exercise 2, exercise 3, exercise 4, home assignment 1, home assignment 2. So that is all for today. We have learned about forces, effects of forces on objects, types of forces. We looked at 2, elastic and compressional forces. So this is what we have learned. Take your time, watch the video again, read the text and answer the questions. We have exercises and home assignments. After everything, if you don't understand, you can ask questions. Use the number over the WhatsApp and the team will attend to you. Your teachers are there, your parents are also there. Go to them if you need further explanation. They will help you. Our books are Science, Asante Tree, Ekuapim Tree. These are the books that we have. And one thing about the science is that the textbook comes with a video lesson. So you just need your phone, you scan the video lesson, which is at the beginning of every topic. So the topic, there is a video for every topic or every indicator. So you can watch the video lesson before you read the textbook, or you can read the textbook before you watch the video lesson. So the video lesson explains the things that we have in the textbook. This is why you need to get a copy. The title of the book is Kokomoti series. Okay, so our videos too are on YouTube, TikTok and Facebook. You can go there and watch all our videos. One thing that I want you to do for me is that after you are finished watching, please make sure you subscribe, you share, you follow, you like, you comment. Please do all the things that you know to help grow the channel. Thanks for your time. My name once again is Paul Williams Ofori. Bye bye.